In the last session, we have seen like what is the introduction
Point
of
offset method.
yes, introduction of ETABS software, lot of basic things, and from its development, what are the different products of CSI. Okay, so that was basic introduction of the ETABS software and its company. Thereafter, we have seen like what is the importance of making the grid lines in the software. Without of having the soft grid lines, you can't go for the modeling, you can't go for the all the next step. To have just to practice with all that steps, you need to have the grid lines. Once you have the grid lines, then you can proceed for the modeling, analysis, design and all. First thing. Second thing is what that we have seen like what are the different methods of preparing the grid lines, creating the grid lines. You know, without of grid lines we can't proceed. That's why what are the different methods, like first one is offset point method is there, second one is your ETABS quick template option is there, and third one is the export and import method is there. And in which situation we have to choose this among any one of these three options that we have seen. Okay, so offset point method normally not in practice. Last two methods are actually in use. That is what ETABS quick template option, and third one is the export and import method. ETABS quick template option is useful when your architectural in plan geometry is simple, not much complication is there. An expert is also recommends that as much as possible proceed with ETABS quick template option, because there will be less chances of modeling errors. There will be what? Less chances of modeling errors. Got it? Our main objective with the modeling step is what? We have to reduce the possibility of modeling error. Got it? So modeling error will be there will be the less chances of modeling error in case of ETABS quick template option, because the proper gradings will be there so that you will get the exact point. Why experts recommend that this option, that you will get in later stages, okay, in later practices. So that is what the second option. Third option is what? Export and import. So if your architectural plan is very complicated and there's no possible to create the grid lines or that architecture plan, in that situation we need to proceed with export and import method. Is that all okay? Up to this level we have completed in the last session. Second thing is what? That we have seen like offset point method we have practiced. Then for some exercises we have practiced for the it has quick template option. Okay, these two methods we have seen. Am I right or wrong? So it is what the summary of last session. Since from the last few examples, we are looking for Cartesian grid system. What? Uniform spacing that we have seen. Then we have seen the non-uniform spacing. So these two grid lines are in the form of Cartesian format. But the third, this grid line we have to prepare in the model. It is what? In the cylindrical form. This is not the Cartesian form. It is what? The cylindrical form. In the Cartesian grid system, your grids will be running along the x and y direction. That is what? Cartesian direction. But in case of cylindrical grid, there is a two direction. That one is what? Radial direction. Second one is the tangential direction. One is your radial direction and second one is what? Tangential direction. So these two direction will be there, and this kind of grid system we have to prepare in the software. So it is not as usual of your Cartesian form. Got it? Is it visible or not? Hello, say yes or no loudly.
Yes, sir.
Yes.
Ashok sir.
Yes, sir.
Okay, so just go to file.
Yes,
Just go to new model. Once you click over the new model, you all know very well about this dialog box. Just come to third option, and first of all you need to look at what is the unit system, in which it is feet and inches or meter in or mm or centimeter. What is it actually? Tell me fast.
Symmetric.
Degree, sir.
Hello. It is metric SI or feet and inches? US customer, tell me fast.
Symmetric.
metric SI. Just go back to ETABS. See, metric SI will be there. It will be Indian. IS 800 2007, IS 456 2000. Let's say simply OK. Once you click over the OK, it will take you all to the next dialog box, that is model model quick template. But let me know, is there any radial and tangential direction option to put the values? No. It is asking to define the values for the Cartesian direction, for the Cartesian grid system. But but that kind of option is not available here. It is blank. It is what grids only. Steel deck. These all are the advanced options are there for the advanced structural definition. Got it? So our main focus is for the first and second option, blank and grids. But it is what Cartesian format. It is the blank one. So there's no any option. Okay, so that's why whatever the definition it is asking, it is not useful for us right now. So what we should do, we have to go with the blank option. Check this option. Let's say simply OK. If you want to define any over height definition, you can set that. But right now we are not interested to define any definition over the height. You all are with me or not?
Yes, sir.
Hello.
Yes, correct. It is plan X and Y.
Okay, so that's why we are going to neglect this thing in plan definition, because it is not useful right now. Yeah, if over height, if any modification you want, like suppose I need to have 10 number of floors over the height in the form of this kind of grid system. I need to have the 10 grids, 10 levels. Typical story height, suppose the 5 meter. Bottom story height is suppose a 2.5 meter. I will let you know later what does mean the number of story, what does mean the typical story height, what does mean the bottom story height. That we'll see in detail later. Got it? So just go to blank and say simply OK, because we don't need to define anything in the Cartesian form. So go to blank and simply say OK. Once you click over the OK, it takes inside of software. This is the Model Explorer. This is what Model Explorer one window. Here the plan view. Here the 3D view. 3D view window is there. So right now we don't need to have this Model Explorer. Why it is needed to have? It is needed to be present here? Okay. So that all things and how to make it to be enabled here. So that all things we will discuss in the command section. Right now I don't need to have this. So just take this, click here and close this window. The plan view will be there and 3D view will be there. Further, I don't need to look at the 3D view right now. So just keep it short. Just take your cursor here and keep it short. This window. I need to have more space in this side, plan view. Got it? So just go to file. See, nothing is there. Actually, what we need to do, we need to create the cylindrical grid system. So go to editor. Hello. Go to editor. Go to edit grid system. Edit storage and grid system. Just check this option. Once you click over this option, over the height, if you want to do any modification, that you can do, right? But right now we are not interested to do anything over the height in plan. But actually the problem is what? In plan, by default, one grid system it is showing. Actually we have not defined any grid system, but G1 represents that a blank grid system is there. Hello, you all are with me?
Yes, sir.
Blank grid system is there under the G1. Got it? So just go to modify and show grid system. So it is what the Cartesian form. So what I need to do, just go to add a new grid system. Once you click over add a new grid system, it is what G2. Okay, a second grid system will be there, and now it is asking whether it should be what, Cartesian or cylindrical. What you want it to be? Cylindrical. Check this option, cylindrical. Now here it is asking what, cylindrical grid system. Grid labeling in radial direction means this is what the radial direction. Okay, so it is what away from the center or towards from the center? It is asking. It is asking what the labeling, how you want to do, away from the center or towards from the center. So by default the software is giving the labeling away from the center. So the center point A, B, C, D in radial direction it is giving the labeling as alphabetical order in alphabetical sequence. See, let me show you. First grid label along the radial direction away from the center. If you want to make it towards the center, that you can do. So what you want to keep it, let it to be by default away from center. Kindly mute your mic who is there. Am I audible or not? Hello.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So see, in tangential direction, all these tangential lines, it is actually giving the labeling to all the tangential direction by the numbering. Okay, in clockwise direction.
Okay.
In clockwise direction 1, 2, 3, 4. If you want to make it as counterclock direction, and or you can say in anti-clock direction, clockwise, counterclockwise. Okay, so
Okay.
clockwise, or in simple you can say anti-clockwise. So clockwise direction will be labeling like this, or if you make it as anti-clockwise direction, it will give the labeling from right to left. So it's your choice. Right now I'm not going to make any change by in default setting. Now grid system origin and orientation, very easy and very simple. Actually this is what the grid system means, grid level. So actually what see, global X direction. So I want to make my center at this point and I need to have my grid system like this. Are you getting my point?
Okay.
Origin, I want to create my drawing and my grid line at origin. So it will be 0, 0. Y direction will be 0, 0. This point will be 0, 0. If you want to shift your grid line, like suppose this is your X and Y origin, and you want to shift by 10 meter in X direction, so your center will be like this and your grid is going to be formed like this. Y is at 0, Y is at X is 10 meter and your Y is what? 0. That's why your grid is going to be present like this. Is that all okay?
Yes, sir.
Okay. So just go to right now I'm not going to make any change. Let it to be as it is. I need to have my grid system or grid lines in respect of your origin. Okay. So that's why 0, 0. Grid dimensions, that's an important thing. Okay. So how many number of grid lines in radial direction? How many number of grids are there in radial direction? 1. See, number of grids 1, 2,
6.
3, 4, 5 and
6.
6. Just go back and put it as 6. Number of grid lines in tangential direction, how many? So how to calculate it? Total angle from this side to this side, total. It is what? 180 divided by unit angle between the two lines. Unit angle between the two lines, how much it is? 9 degree. 9 plus 1. This will give the number of tangential lines. Okay, how much it will be? 20 plus 1. It is going to become what? 21. So that's why it will be what? 21. Just go back to your ETABS and put it as what in tangential direction as 21. And spacing of grids in radial direction, how much spacing of grids in radial direction?
4 meters.
4 meter. So just put it as 4 meter. And spacing of grids in tangential direction, what is angle? It is asking about the angle.
9 degree.
So unit angle
9
is what?
degree.
9 degree. Just put it as 9. So this is all the definition we have defined. Let's say simply OK. Once you click over the OK, so one more grid system where is added. First one is the blank one. Second is a cylindrical one. Let's say simply OK. Once you click over the OK, see the grids is now it's looking like this. Hello.
Okay, sir.
Just go to, if you want to increase the visibility, go to edit, go to edit grid system, and in this option go to modify. Sorry, in the second option, second grid system, go to modify and show grid system. I need to have some different color, less red color, say simply okay. Some dark color I need to have, some dark color, say okay, then simply okay, say simply okay. Now see, a 10 number of floors I have defined, and accordingly I am having this kind of representation. Hello. So yeah, so in this way you can create this kind of cylindrical grid system. And suppose you want to shift this grid by 10 meter in x direction, as we have discussed earlier. So go to edit grid system, and go to second grid system. Just go to modify and uh, edit and modify grid system, and I want to shift this option was earlier also available, for that I'm talking about. Okay, so in x direction it is 10 meter. I want to shift from the origin in x direction, y is 0. Let's say simply okay, say okay. See, it is shifted by what? 10 meter in x direction. If you want to further shift in y direction by 10 meter, so go to edit grid system, go to modify, and modify grid system. In y direction also I want to shift it by 10 meter. Let's say simply okay. Let's say simply okay. Hello. No, I just want to have this grid system at origin, but I need to have the inclination by 30 degree. I need to have the inclination by what? 30 degree. Okay, inclination by 30 degree. So go to editor and go to editor, go to edit grid system, second option, just go to modify and change it to what? 0 0. I need to have at the origin and put it by 45 degree or 30 degree, whatever you want. Let's say 30, and say simply okay. You all are with me or not?
Yes, sir.
Repeat, sir.
You
Yes,
may ask that, sir.
Yes.
Yeah, here is a uniform spacing between the two tangential direction. Okay, uniform spacing. If suppose we are getting the case where first is 9 degree, where second is 11 degree, where third is 25 degree, where fourth is 35 degree. Likewise, it may possible or not.
yes, sir. It
Then
is
what we have to
possible.
do in that situation? Okay, so make it for first as we have done for uniform angle, for uniform angle. But after having this grid system, okay, first go to editor, go to edit grid system, go to second option, go to modify and change it to 0, and simply say okay, say okay. Now go to editor and go to edit, and second option, go to modify, and this situation along the tangential direction. Okay, and also in radial direction you want, if you want you can make the modification. You all are well aware with these options. Am I right or wrong?
Yes,
So
sir.
what's the problem
Yes,
with you
sir.
all? You all
Very
know
correct.
very well. Am I right? Hello.
Yes, sir.
Yeah. Here, suppose you want to have this 18 number, like it is 18 degree. Here it is having what? It is what? 18
38
degree.
degree.
So it is again 18 degree like this. So what modification will be there? We will see. See, this kind of your grid system is going to become. Hello.
Okay, sir.
So that kind of variation will be there, that you have to tackle, that you have to deal with. With that you have to deal with. Am I, is that all okay? Will you do that?
Wherever we want to make changes in degrees, we can make there.
Yeah, individually for each grids, go to edit and second option modify. Here you want to do for each distances, for each inclinations. Okay.
Okay. Okay,
Yes.
sir.
Second one. Okay, so yeah, this is all about this cylindrical grid system. So we have covered Cartesian one, we have covered the cylindrical one. Both of the options we have covered. Now the fourth type of grid system that we have to prepare here, this type. And you will suggest me how I can prepare this grid system. Let me just tell me fast. that you have to prepare this, and as you guide me, I will do that. Fast, tell me, what type of this grid system? Can anyone guess?
It is a combination of two grids.
It is a combination of two grid system. Okay, anyone else? Fast.
Combined grid system, sir. Am I right, sir?
Yes.
This is orthogonal and cylindrical.
Yes, Nadia. What you said?
Am I right? I said it is combined system, combined grid system.
Combined grid system. Okay. Anyone else? Digambar.
Grid G1 are there. Grid one we can edit.
Akshay. Yes. Tell me.
Means
G1 वहाँ पे है तो हम उसको edit कर सकते हैं ना वहाँ पे.
हाँ नहीं, ये ग्रिड सिस्टम कौन सा ये बताइए पहले. दिगंबर.
Point method sir. Offset point method.
Yes, sir.
Yes. What type of this grid system?
Combined grid system.
Okay, so it's very simple. It is combined grid system. Okay, it is having both cylindrical as well as Cartesian one. Okay, so how I can do this? Go to file, go to new model, and say no, and go to third option. Just see it is SI system or US customer system. Which one? SI.
SI.
So take this.
SI
okay.
system.
Yes. So, is it needed to work with this Cartesian option? Yes. So, there are two grid system. First, we create this grid system, and then we will add one more grid system as cylindrical one. Okay. So, very simple. First, go to ETABS and first create the Cartesian one. So, in X direction, how many grids are? 1, 2, 3, 4, 5, 6, 7, 8. So 8 number of grids are there in X direction. So put it at 8. In Y direction, how many?
4.
4. Just put it as 4. It is uniform, non-uniform, fast.
Non-uniform.
Non-uniform.
It is non-uniform. But is there any repetition in X direction? No.
X
In Y
direction,
direction? No. So let it to be as it is, whatever. That doesn't matter. Go to custom, anyhow you need to go with, and go to edit grid data, and with which option we have to work, either first or second?
Second, sir.
Second, good. Go with the second one. So here in X direction, fast, 5.9, 10.2, 5.9, 10.2, 9.6, 5.3, 9.6, 5.3, 6.2, 9.1,
3.9.
6.2,
3.9.
9.1,
3.9.
3.1.
3.9. Is that all okay? For the last, is there any need to put
0.
0? It will be 0. Okay. Good. Very good. Just go back. 5.9, 4.9, 5.8, 4.6.
Yes, sir.
4.9,
5.8.
5.8, 4.6. Am I right?
Yes.
And see here, instant view option is available. Whatever the modification that you are doing here, it is updated here. So you can judge whether your grids are presenting right or wrong. Getting? Hello?
Yes, sir.
Yes, sir.
Yeah. Suppose here I am going to put 14. So accordingly, that window show you the modification. Are you getting? Hello?
Yes. Yes. Oh,
Yeah. So that's why you need to look at that. Okay. So yeah, here I am going to take some dark color for the better visibility, and bubble sizes you can change. Right now I am going to say okay, and let it to be as it is. Over the height we don't need to practice anything. Let it to be as it is. And whether you want to have the grids or not, or you want to go with the blank, tell me fast.
Grids. We need grids.
Okay. So check this. Akila, are you there?
Yeah, I'm here.
Okay. So whether you want to have the grids or not, Akila.
Yeah, we should have the grids.
Okay. So just go to grids option. Let's say simply okay. After this, just close this, and I don't need to work with this cylindrical I don't need to have this 3D view. Close this one. So we only have the plan view. Okay. So this is all done. But what? We need to put one cylindrical grid. So can I put cylindrical grids in this Cartesian grid? No. I need to add one more grid system. So go to edit grid system, and in this grid system, what I have to do? Can anyone guide me?
Add new grid system.
Okay, just go to add new grid system, then
Cylindrical.
okay, cylindrical, then here it is asking about the positioning of your grids. It is asking
Yeah,
about
X
the
and Y
positioning.
options have to
So
be
tell
there.
me, what is the positioning? Actually, if I am considering this is the origin, if suppose I am considering this is the origin, 0 0, okay, suppose it is your origin, so it is at the origin or not? No, it is not at the origin. Then you have to find this distance where it is located. Hello.
All right.
Yeah, so I need to find this x direction, x distance, and this is y distance I need to have. Hello.
Okay, sir.
Okay, so how I can calculate this? Very simple.
Why-
Just add
why
this
is
for
it-
all values 1, 2, 3, 4, 5, 6, 7. All these values you have to add, and then minus 2, 4, 6, 8, 10. 10. Find out the total of this value.
40.2.
Sorry,
40.2.
who said 40.2?
40.2.
40.2 minus 10. How much it will become?
30.2.
30.2. Is it right? Hello. Yes. Let me check it once. Can anyone cross check this value? Hello. Okay, we'll do from here.
Sir, final value
5.9
40.2.
plus 10.2 plus 9.6 plus 5.3 plus. In every session you have to keep Cassie and pen and notebook with you all. Okay. Plus 9 point, and when I'm delivering this session lecture, you don't need to do anything. You don't need to practice. Okay. You just have to answer to my question, and you have to put your doubts. How much it is? 50.2 actually. Hello.
Yes, yes, 50.2.
Yes,
It
sir.
is 50.2 minus 10. Then it will become what?
40.2.
40.2. Okay. He said directly 40.2. It's okay, no issue. 40.2 in x direction. So just go back to ETABS and put here in x direction 40.2. And for the y direction, how much it will be?
15.3.
4.9, 5.8, 4.6. This distance. So just add these values. 4.9 plus 5.8
10.3, sir.
plus 4.6. Say equal. How much it is? 15 point?
3.
Hello.
15.3.
Right or wrong?
Yes, sir, 15.3.
15.3. This is done. Any rotation? Any angle is there? Hello? No. Number
No,
of grid
no.
lines in radial direction. Can you tell me how many grids in radial direction? 1, 2, 3, 4, 5 and 6. Just put in x direction 6. In in tangential direction, how many it will be? This is
11.
180 divided by, angle is not given, but the angle is actually 18 degree. Hello. Angle how much? Hello.
18 degree.
18 degree. 18. What is the formula?
Plus 1.
Plus 1. How many number of tangential grids?
10 plus
11.
1. 11.
11 number. Okay. So just go back and put it as 11. In tangential direction it will be 11. Spacing of grids in radial direction is 2 meter, and in tangential direction it is 18 meter, 18 degree. This is all done. Let's say simply okay, and just simply okay. Once you click over the okay, so your cylindrical grid system is now available here, but the visibility is very less. So go to edit grid system, go to second option, go to modify, and change the color from gray color to yellow. Some dark color I will refer. Say okay. Say simply okay. See, hello. Is that all okay or not?
Yes, sir.
Yes, sir.
So
Sir,
in this way, you can,
by this grid bubbles are means grid labels are crossing the this one means like
sorry.
means वो grid जो है ना सर grid labels तो वो means क्रॉस समथिंग इम्प्रॉपर दिख रहा है नहीं
No, इतना आपको ये कैसे है? Hello.
यस सर
That you have to understand, that you have to manage. Okay.
okay means
Yes.
when we'll add this to means such kind of system we might get this kind of image.
Yes. Yes. Yes.
Can you show this in 3D view?
In 3D view. Okay. Let's see.
All right.
This kind of. Is that all okay or not?
Yes, sir. So this type of shape, where can we expect to have?
What?
Means this type of shape, where we can expect to have in structural systems.
That in any kind of mistake, it's the choice of architect. If it is going to plan something like this, so you have to ready for that kind of preparing the
Okay.
model. Okay.
Okay.
Like
Okay,
you
sir,
don't,
got it.
while in case of any kind of structure, if you are going to design any kind of bungalow, and that is depends of having the domes. Okay, so what you can
Okay.
do in that situation, you have to proceed with this grid system.
Okay.
Am I right?
Means for like architect used to consider aesthetic views. So
Yes, for the aesthetical purpose,
mostly
we can refer
there
this
is
kind of complication.
okay, sir.
Yes.
Yes,
Can I
sir.
ask one question?
Yes.
Does the software has the capability to model non-circular curves like parabola or ellipse?
Yes.
Those
Every
kind of
kind of
curves.
model you can create, sir.
I see.
Okay.
Okay, thank you. Okay.
Okay. Yes. Can we proceed for the next?
Yes, sir.
Okay.
You may
So
proceed.
this is all about the preparing the grid lines in the software itself. So this is all the simple thing that we have covered, but it is more than enough for this stage. But when we come to the real project, then we will actually practice for the real project how to create the grid lines and how to proceed for that. Okay. But for this instant, for the instant, it is more than enough to have the knowledge that we have covered since from the last session. Okay. So
Okay,
this is
sir.
about the grid system preparation by the ETABS quick template option. Means what? Here the grids we are going to prepare in the software itself. And why it is recommendation by the expert to go with this grid system? Because when you are going to find out the point, so you will get exact intersection of these two lines. If I am going to prepare anything from this point to this point, so that will be the exact present exact
Line
modeling will be there. There will be no chances of modeling error. Okay. So this kind of things we have to understand. Now the next option that we have to see is export and import method. So in that situation, what if your architecture plan is complicated? So in that so that we are going to export the CAD drawing directly. CAD drawing means what? The center line plan, and that center line plan we are going to import in the ETABS software, so that we don't need to create the grid lines in the software. Got it? So just go to see. Is it visible to all of you?
Yes, sir.
Okay. This is the grid system. Sorry, this is the center line plan. How you will get this center line plan? So that's a total different thing, and lot of things that's needed to discuss, and there a lot of things we need to do. Then we will get this kind of center line plan. But instead of all that, we are directly going to look at how you can export this center line plan uh, from the CAD, and how you can import this center line plan in the ETABS software. Okay, so for the exporting, suppose this CAD drawing you are having, but before of that, okay, just go back. Suppose this is your structural framing plan. What does mean the structural framing plan? A structural framing plan means what? That represent the structural system like beams, columns, shear walls, column labels, beam labels, slab labels. After having that structural framing system or beam layout, we have to prepare the center line plan. And once you get the center line plan, that we have to take outside of your beam layout, and this is your center line plan. Suppose we are having the structural framing plan, and we have prepared this center line, and that center line we have taken outside of this beam layout. Now I need to have this center line plan in the ETABS software. So how to do that? So very simple. First drag it and select this entire drawing of center line plan. Hello. Okay, then just press Ctrl C. Actually we have to copy this, and we have to take all this drawing in the new CAD file. Hello, just open new fresh CAD file, close this, and that file you have to paste here. Just say Ctrl V, and this file is going to be we are going to put here. But while taking this drawing in this new drawing file, just put 0,0, because we need to have this drawing at the origin. Hello, just say simply enter. So this drawing is going to be shifted, or is going to be positioned in respect of its origin, means in reference of origin. Hello.
Once repeat, sir.
Why we are doing this, you will understand it later. Hello. What first step? Open your drawing which is having a structural framing plan, prepare the center line plan, and after that we will have the center line plan. That center line plan you have to take outside, and you have to create a new file. There you have to save this file. Okay, then go to file and just say save as. You have to save this file. Just go to this desktop and just delete folder, and just create a new folder like batch 8. Okay, let me create here. Okay, in this new folder 2, and this just say batch 8, and you have to save this file in the form of what? DXF file format. Why I am going to save this file in DXF file format? Because when you are going to import a CAD file in the ETABS software, the file format should be what? DXF, not DWG file format. Remember. Hello. Okay, so file format will be DXF. In DXF file format you have to save this. Just say save. So this file is actually saved, and in DWG format is also asking to save. Okay, just close this. After that, save this file in the form of DWG also. That is not needed. Actually you need to have the DXF file format, nothing else. Then go back to the ETABS and go to file, go to new model, say no, and with the third option, with the metric SI, Indian, and IS 2007, IS456 2000, all these things will be there. Let's say simply OK. Once you click over the OK, see, just go to custom. Sorry, here we don't need to put anything. If you want to put any override data information, that you can do. Otherwise you don't need to put anything. Just go to blank. Check this blank option. Let's say simply OK. So nothing will be there. Nothing will be there. Now close this. I need to have only the plan view. And one more thing, how many levels are there? Just you need to remember. How many levels are there? Hello. Go to plan, base, story first, story 2, story 3, story 4. How many levels are there? First,
4.
4. 1, 2, 3, 4. This is the base is actually your foundation level. This is your base, which is actually your foundation level. So that's why we are going to take first, second, third, and fourth. 4 level is there. Just remember this. Okay. Then go to file, go to import. Hello.
Okay.
In import option, see, go to .dxf file of architectural grids. Just check this option. Once you click over that, go to your base folder where your file is saved, desktop, in folder 2, sorry, in delete folder 2, batch 8. Is it visible?
Yes, sir.
Check this option. Let's say simply OK. Go to file, go to import, and go with this first option, .dxf and /.dwg file of architectural plan. Check this option and choose your file. Say OK. Now you will have this kind of a dialog box. Architectural plan import. So what is the unit? That you need to remember. What is the unit? It is feet and inches or in meter or mm. What is this? What is that? So you need to make sure that what is the unit system. Okay, so metric SI system is there. Okay, but it is in mm or unit. It is in mm or in meter. What it is? Tell me.
Meter.
It is in
Meter.
meter. So just go back to ETABS and just change it to meter. And where you want to import this drawing? Tell me.
So story 1.
At story 1, at story 2, story 3, story 4, where you want to import it. So I want to import it at the story first. Check this. And these all things will be as it is. No change is needed to do here. Let it to be. Only these 2 things are very important. Just say simply OK. Once you click over the OK, okay, so where we are actually at the 4th level and where we have imported the drawing?
First level.
At first. So we are at the story first. That's why we are unable to see. Go to plan and come to the story first. Let's say simply apply. See. Why it is not showing in the plan view? Just say add a new window. Here, go to plan, story first. Okay, some kind of go with the third option. Let it to be all as it is. Say simply OK, and we don't need to want anything. Let it to be. Go to file. Go to import, go to architecture plan,
DXF floor plan.
take this, make it as meter. We want to have at the first story, so simply OK. Close this, go to plan and come to the first. Why it is not having?
So,
Wait for a minute. Meter. We are taking this center line. Zero one. Save this file. No. Sorry, something is wrong. Go to file. Go to import. And in this architecture plan only you have to practice. Check this. And this one. Meter.
so
Yes, tell me.
once you may select DXF floor plan, maybe that option will work.
No. It is okay. It is right, but why it is creating the problem? I'm not getting.
Okay.
We have to
Right.
close the DXF file.
Sorry.
You have to close the DXF file.
Yeah, that DXF file I have closed.
Okay, sir.
Yeah, that I have done. But actually, if it is not closed, it will not accept at all. Okay. It will ask to first close the file.
Okay.
Are you getting?
Yes,
Go to
sir.
file.
Means AutoCAD file we have to close first.
Yes. It is first asking to save or close the file. Otherwise, it will not accept at all. But here it is accepting. Why it is not presenting? That I'm not getting. Okay, we'll sort it out. Say okay. And go to blank. Say simply okay. And now close this. Close this. Now go to file. Go to import. Go to DXF file of architectural grid system. Check this option and this batch 8. And no, this option is not okay. Go to file. Go to import. DXF file of floor plan. Check this option. Take this.
So you gave origin as 0, na, sir? So this option will work, I guess.
No. See, hello.
Yes, sir.
Now it's having. Actually, the same process is there. Hello. What you have to do? Go to file. Go to new model. Say no. Hello. You all are with me?
Yes, sir.
Okay. Go to file. Go to third option. And with this option, say okay. Make sure that the unit system will be same as that of your plan, your Centerline plan. Okay. So here the unit system is meter in metric SI and the unit is in meter, not in mm. If it is in mm, you have to choose the mm. Okay. While importing. So just go back to your ETABS and just go to blank because we don't need to create the grid lines in the software itself. That's why I need to have the blank. Say simply okay. Once you get into the software, now close this 3D view and go to file and go to import because we want to import the drawing from other softwares. Okay. So go to import and in import you will get the option a .dxf file of floor plan. Sorry, this one .dxf
File of architecture plan.
Yes. First option and unit is what? Drawing unit is what? Meter.
Meters.
And we want to import the drawing at the first floor. Rest of all things will be as it is. Let's say simply okay. Once you click over the okay, we are at the 4th story. We need to come to the first story. Come to the first, say apply. Now see, your drawing is now present here. Hello.
Okay.
So how smartly and how easily you are getting your drawing to be imported. But if you are going to create this center line by preparing the grids in the software itself, so it will be very complicated and it will time consuming. It will be what time consuming?
Excuse me, sir. To
Yes.
come to first story, which icon you pressed?
Sorry.
To come to story 1, which icon you pressed there? You clicked
Okay.
chose there.
This option plan. I will let you know all these options. Okay. Everything I will explain. Hello. Akila.
Yeah, okay.
Okay. I will let you know every options I will cover. Don't worry. Okay. So if you want to move over the height, so you go to plan and all the stories will be there. You have to click over that story so that you can access that particular level. Okay. So I need to come to the story first. Say apply. So now we are at the story first. Hello.
Okay, sir.
Okay. So it's very simple. In this way you have to import, but after importing you have to make sure that whether your imported drawing is right or wrong, whether dimensions are right or wrong. Because suppose you are in your architecture plan, in your structural framing plan or in your center line plan, it is what approximately 6 meter 5.97, but in imported if some mistakes you are doing, if you are not taking the care of that and if you are doing the blunder, so what will be there? Suppose after importing you are getting like 50 suppose 5.97 799 mm it is showing. Then what you can do? While making, while importing, instead of taking meter, you are taking it as mm. So
So
drawing
we
will be
can
represented by the
overlap.
mm, and your architectural plan is what in meter. Your
Oh,
structural
yes.
framing plan is meter. So it is the big blunder or not? Your
Yes,
all
sir.
design result will be wrong. Hello.
Yes, sir. You are right.
It's a big blunder. Your all design results will be totally wrong, not acceptable. So you have to make sure that whether imported drawing is right or wrong. So how you can check that? So go to editor, go to draw, go to draw, go to draw dimension lines, draw dimension line. Just close this from this first point. Take the cursor to this point and let's see what is the distance.
5.9.
5.9735 meters.
735. It is exactly similar to your center line plan or not?
Yes, sir.
Yes, exactly.
Exactly. So that we can proceed for the next step like modeling and all. Okay. If you are means blindly, if you are going to do, you are proceeding for the next step, it will be wrong. Okay. So this care you have to take. Got it? So that this is the method of importing the drawing in the software. Is that all okay?
Yes, sir.
So very simple. First step is what? You have to create the center line plan. Once your center line plan is ready, you have to take that center line plan in new CAD file. In new CAD file. New.
Yes.
I'm summarizing this process. New CAD
Okay.
file.
So we can even purge the layers, and we can have this plan with the help of block edit in place, right?
Sorry, I'm not getting.
Means there is one more option, instead of copying this center line plan to another CAD file. uh, there is option in AutoCAD, block edit in place. First we can whatever the plan is there, we can off the other non required things. We can off those things, and we can just
No, that will not work. That will not work. Because whatever the things in your drawing, that all is going to be read by the software.
no, sir. After doing work with block in edit place, we have one more option. Means after extracting our center line plan in the same drawing, we can off. We can, with the help of command purge, we can off the other layers, and we can have this center line, only center line plan.
Yeah, I'm getting
In
your thought, but that will not work if you are going to import the entire drawing. Getting that is the another option that you are saying. In that situation, you don't need to off the layers also. They need to be present, but only the
Okay.
required things you can import in the software. If time
Okay,
will
so the
allow, I will let you know that
best
option
option
also.
is this one.
Yeah. Best option is this one. What option that you are asking, that is also correct. Like suppose if you are creating any plan. Suppose that any plan is there. One plan is of one thing is of one layer is of your column, one layer is of your beam, one layer of your slab. And what you are saying that suppose I want to import only the lines. Hello.
Yes, sir. Yes, sir.
I can off these all layers, right?
Not my center line plan layer, sir. The other means other than center line drawing, other than center line drawing, we can off those layers.
Yeah. I'm getting. Means you want to keep only the center line layer to be active. Other all other are inactive form, right?
Yes, sir. Yes, sir.
Yeah, that I'm getting. So that's why I'm saying that whatever the elements are there, that you want to keep it as off. And suppose only the beams you want to keep beams like beams or lines, whatever. If you want to import, you want to keep it inactive. So, but it not work. There is another option that you are saying that is also practicable. That we With that option also we have we can have this kind of drawing.
Yes,
But
sir.
that is the another option. Okay.
Yes, sir.
Yes. So I'm going to summarize the process. So you have to prepare the Centerline plan. That Centerline plan you have to save in a new CAD file. Okay. And you have to save that file in addition to DWG format. You have to save that file in DXF file format, because your ETABS software is asking the file in DXF file format. It is showing that it will allow the DWG format also, but that will not work. Go to import file,
Okay.
go to import, go to see it is asking what DWG also, but
Okay.
it will not work. Okay.
Uh-huh.
Now then that exported DXF file you have to import after closing that file. Okay. Otherwise if your file is open, that will not be imported in the software. It is asking to close. Once everything is okay, you have to save the file in DXF file format, and then you have to import. After closing that file, you have to import in the ETABS software. After the importing, you will have this kind of drawing. And after that, you have to make sure that the units are same, dimensions are same, lengths are same, everything is same. Then you have to proceed for the next step. Is that all okay?
Yes, sir.
Okay. Now clear this all. Can you proceed for the next exercise? So this is all about your grid lines. How to prepare grid lines in the software. Now next step and next exercise will be what? In this exercise, we have to validate the software for the importance of some important structural elements, like whether your software is giving the correct result or not. If you are giving the right input, so software should give the right output. Okay. So like small elements like truss, beams, okay, different kinds of beams we will discuss, and we are going to load that beams, and we are going to analyze that elements, that structural elements, and we are going to look at the results, and we will compare that results with your manual calculation. So if your manual calculation, if the ETABS result is exactly matching with the manual calculation, then we can say that your ETABS results are correct. Because your manual calculation that we are going to see, it is right. So if we are giving the right input, the software should also give the right output. And means if the software is not giving the right output, then we will not trust on this software, we will not use this software. Am I right? Hello. So basically what we have to see, the we have to practice with to know whether your software is giving the right result or not. But along with this exercise, we have to learn so many things. Our objective is what? The validating the software. But along this validation of the software, side by side, we have to learn so many things. Hello. Am I audible or not?
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So first we have to understand, like what is the neutral axis system, local axis, natural axis system, local axis system, global axis system, that you will come to know after this exercise. What does mean by the releases, how to assign the releases, what are the different types of the elements in the software, that you will come to know. What are the different types of the supports in the software, how to assign the supports, what are the different types of the loads, how to assign that loads, what are the different types of the forces, and how to see that forces in the software. Okay, what are the different types of the movements, how to see that movements in the software, and how to see the reaction at the base of the structure. Okay, so many things along with this exercise we are going to learn. So you all are ready? So first of all, what are different types of elements present in your software? So there are two types of element present in your software. First one is what? Frame element. First one is what? Your frame element, and second one is what? Your shell element. Hello? Your frame element and shell element. Frame element will include your beams, columns, spindle. Okay, so these all are the all are what? Your frame element, line element, and second one is your shell element is what? Your slabs,
Walls.
and what? Shear
Walls.
wall. These
Yes.
all are what? Your shell element, and this is what? The frame element, line element. See, both of the elements are 3D elements. They are having the length, they are having the width, they are having the depth, length, width, depth. Shell is also having the length, width, depth. Both are same. Then why these differences are there? Why? Because these frame elements, it's a length along the longitudinal direction. This dimension is very large. See, if you are talking about the beam, so beam is having the very large dimension, very large span along its longitudinal direction in comparison of its two transverse directions. Transverse dimension means depth is less and width is less in comparison of its length. That's why we are going to call it as line element, or in the software language we are going to call it as frame element. Hello. Now, next, if you are talking about the shell, so for the case of the shell, so same thing is there. If you are talking about the slab, so slab is having what? Suppose the 5 meter length is there of the slab, and the 4 meter is the width, 5 and 4, and depth is only what? 120 mm. So see, is there any comparison between these two? 5000 mm or 120 mm. Is there any comparison? Hello?
No.
No, it is very less. That's why we are going to call it as shell element. It is what? Shell element. Only the depth is very less, and that is the same case for your shear wall. Shear wall is also the same, which is having like this kind of presentation, be a shell like this. So only width of this shell or shear wall will be very less, like 230, 200, 150, and other two dimensions are very large. That's why we are going to call it as shell element, and it is what? The frame element we are going to call. So in ETABS software, there will be two types of element. One is your frame element, one is your shell element. You have to remember it for the complete training. Is that all okay? How many types of elements in the software?
Frame element and shell.
Frame element and
Shell
shell element. Now, what are the grid systems? Axis system. There are three types of axis system. One is your neutral axis system, then local axis system, or then global axis system. Hello. Or in reverse direction, you can say first is your global axis system, then local axis system, and then natural axis system. Can any one of you can define what does mean by these all three axis systems?
Space system.
Sorry,
XYZ space.
space system. Okay, for that you can say Nazia.
Global system is defined as universal axis or grid system of.
Global is for a whole model, and for individual element like beam column, that is natural, and for element it is local.
Okay, you all are partly correct. See, there are three axis system. One is your global axis system. The axis system which is going to represent your entire model. The axis system which is going to represent your entire model, that we are going to call it as global axis system. Hello? Because your model is actually the 3D, your entire model is 3D model.
Yes.
It is the 3D model. It is having something along its height. It is having something along its width. It is having the something along its along this x direction. It is having something along this y direction in plan, and along the z direction. So all the elements which is running along this x direction, that we are going to call along, the element is along x direction. All the elements which is oriented along this direction, we are going to call it as along y direction. All the elements that is running along this z direction, we are going to call it is along z direction. There may be a column, there may be any like a shear wall is there, so that I can say it is running along the z direction. Column is also running along the z direction. So all the elements which is along the z direction, along this vertical direction, it is represented by the z direction. Means it is representing, this axis system is representing your entire model. That's where we are going to call it as global axis system. Is that all okay? Hello?
Means
Yes, sir.
in global axis system, 3D views are means it is defined by the 3 dimensions.
Yeah, it is not means compulsory. Suppose
All 3 dimensions are considered in global axis.
in global axis system. Means it is what? This one axis system is representing your entire model. Okay? This axis system is representing entire model. Suppose the y is not there, only x and z. So what it will define? In this direction, whatever the things is in x direction, all the things which is in vertical direction along the z. But how you can define these? So that for that you need to have this third direction as y. So the unit that's the axis system which is representing your entire model, it is called as what? Global axis system. Now come to the one, come inside of one more inside of this step. What? Like suppose I am coming to this particular element beam. I am coming to this particular element which is column. This is also a 3D element. If I am taking it outside, so I will get this kind of drawing, this kind of element. So it is also 3D element. It is having its width, it is having its length, it is having its width, depth, length. So for defining its length, for defining its width, for defining its depth, length, width, this element is need to have its own axis system, and that own axis system of this element called as local axis system. Hello?
Yes, sir.
This is what it is. It is basically global axis system. Entire model is represented by. If you come inside of this, each element is having its own unit axis system. Hello?
Yes, sir.
This length. See here very simple. अभी यहाँ पर आपको understand समझ में आ जाएगा ये. See, this suppose 5 meter. Suppose okay, one more will be there like this. This is what? 10 meter. This is the 5 meter. 5 meter, and this is the 5 meter. So in x direction, what is the dimension in x direction? Total end to end
10 meter.
10 meter. But if I am coming to this side, now I have to find out the distance in for this particular beam. So it is represented for whole member, for whole model. It is represented by what? Global axis system in x direction. But if you are coming to this particular beam, so in one direction, the beam having what? 5 meter. Hello? So it is what? For defining the definition of this dimensional definition of this particular beam, we need to have the axis system, its own axis system, that is called as local axis system. Not only the dimension, everything. If I want to see the forces in this direction, so I need to look axis 1 1. if I need to see the forces along the depth, so I will access the 2. Are you getting or not?
Yes, sir. Yes, sir.
Hello. So it is called as what?
Local access system.
Local access system.
So,
Okay.
so one represents any
Length of the beam.
global
Three.
plus local means with respect to global.
No. There's no any relation of this. There's no relation. There's no any relation of this local access system with the global one. No any relation.
All
Okay.
right.
It is totally different. Whatever you want to see in this particular beam, in along the length of the section, along the length of the member, you need to look axis 2. Whatever you want to see for this particular beam along the depth, you need to look axis 2. Whatever you want to see along the width of this member, you need to look axis 3. That's it.
Okay.
There is no any relation with your global axis system. Hello.
All right, sir.
Okay. Now this is called as global axis system. This is called as local axis system. Now what does mean by the natural axis system? Now I am going to I am getting inside one more step inside of this particular model. पहले हम लोगों ने complete model को देखा. Then we have seen like this particular element beam. Then we are moving inside of this particular beam. So this model, this particular beam element is made up of small particles, solid particles. Am I right or wrong?
Yes, sir.
This is accumulation of small solid particles, summation of small solid particles that will make this solid beam element. Ashok sir.
That is correct.
Okay, but this solid element is also having its 3 dimension, length, width and depth. Right or wrong?
Right, sir.
And for defining its length, width and depth, we need to have the particular axis system, and that axis system we are going to call it as what?
Natural axis system.
Natural axis system. Is that all clear?
Yes, sir.
Okay. So the global axis system, local axis system, natural axis system. Now come to the software.
So, sir, generally, this natural access system is not in work.
I will
Means
let you know
not in
which is it.
consideration.
I will let you know. Wait.
Okay.
Hello, is it visible? What is this system? Can you guess?
Global access system.
It is global or local?
Global.
Global.
It is
sir.
global axis system. Got it? If suppose I want to see the local axis system, so go to set display option. How to see that I will see. I will let you know. Only understand the thing. Okay. Don't worry about how to see. I don't know about how to see these all things. That all things will come later. Only I would like to show you how you can see in the software whether it is present in the software or not, whether it is useful or not. That all things I have discussed. It is not just for sharing the knowledge, because it is useful. Okay, it will be we have to practice with all these all things. See, it is available or not. Now tell me, it is local or global?
Local.
It is a local axis system. So one is your global axis system and one is your local axis system. Now suppose I don't need to look at the local axis system. This is a global axis system. So it means what? All the elements like this beam in this direction, this beam, all the beams along this direction is along X. All the beams which is along this Y direction, it will along Y, and all the elements which is along the Z direction is along Z. Along the height is along the Z. So
Yes.
this is what global. If I am coming inside of this model, and if I want to see the dimension or any kind of property for this particular beam, so I need to look at the local axis system. So go to local axis and object assignment, local axis system, check these options, say apply. So this will be in view.
Okay.
Hello. For all the frame element, how many types of elements are there? Frame element is also there and shell element is there. So here right now we are looking for local axis system for all the frames, local
Yes,
axis
sir.
system for all the frames. Now go to set display option, and I want to see for the shell element, like for the slabs also, for the shell elements, say apply. Not see, for all the shell elements local axis system is now present here. Clear?
Yes. Yes, sir.
Understood?
Understood.
Okay, this is for the slab. Okay, this is called as global axis system, local axis system, and this natural axis system it is not in practice, and that is not because if you are doing any research work and any kind of deep work and study work, at that time you have to look at that. Okay, but in software you are not able to see the natural axis system. Okay.
Yes, sir.
So these two things in practice, global axis and local axis. Is that all clear or not? Hello. So I have to model this truss. I have to model this truss. First of all, you might be practice for the making the calculation of or making the analysis, manual analysis of this kind of truss. And there are some assumptions. Can you recall what assumptions are there for analyzing the truss? What assumptions are there? Can you recall?
Determinant truss or indeterminate truss?
No,
No.
there are some assumptions.
Like members can only carry axial forces like tension or
Yeah, members
compression,
can carry only axial forces. All the loads
and all
are
the joints
actually,
are hinged.
yeah, all the loads will be at the point, at the ends of the elements, at the joints only, right? All the members are connected at their ends only,
Okay.
right? All the members having the uniform cross section. Self weight of the
Yes.
member were neglected in the analysis. All the connections are pinned connection or hinged connection. It means what? The joints are not going to carry any kind of movement. Only there will be a transfer of axial forces, and the nature of the forces in each elements of the member, each elements of the truss will be what? Axial forces, whether it may be tension and compression. I am saying everything right or wrong.
Yes, sir. You are right.
Okay, this is a basic assumption you all might be learned in your academics, in your diploma, whatever you have done, diploma, degree, engineering mechanics, in structural analysis
Yes,
subject.
sir.
Okay, so Chandradev,
Okay, sir.
are you there?
Yes, sir.
Okay, so see these all things. So that assumptions are there. Along with that assumptions, we have to proceed for the modeling of this truss. I have to model this truss, and some manual results are there. I would like to see whether my software is giving the right result or not. So with this exercise, you will come to know how to assign the loads, how to assign the supports, how to see the forces, and then how to validate the software, how to create this model. Okay, so just go back to ETABS, go to file, go to save new model, open a new file, say no. So first go with the third option, find out the unit. It is metric SI or else? Tell me.
Metric,
Hello,
metric.
metric SI. Okay, Indian IS 800 2007, IS 456 2000. These two codes will be there. Let's say simply OK. Once you click over the OK, now come to this. Tell me how I can create the. Okay, How you can create this? How many grids in X direction can you guess?
4.
Anyone else? First tell me, it is 2D frame or 3D frame?
2D frame, sir.
It is 2D. Means it is along two direction. So, or along one plane. So it may be like this. The one plane, another plane will be like this. Two plane. So this is the Y or Z direction is fixed for both. And here it is X. Sorry, here it is X. Here it is Y. Y in plan. So either you can consider your model in this XZ plane, or you can consider this in YZ plane. That is your choice. So here we are going to consider that our model, our structure is along what? Z and X plane, right? Hello. Z and X plane. Now let me know, like along Z and X. So along X direction, how many grids will be?
7.
7 grids. Okay, good. Tell me anyone else. Anyone else? Fast.
In X direction, 7 grid. And
7 grids. Look at the drawing. How many grids will be there along X direction? Hello. Yes.
3, sir.
Akila.
7, sir.
How you can say 7? Along X,
3, sir.
don't count this
3,
one.
sir.
Don't count. This is along Z. Over the height
3,
it is.
sir.
And along X, how many grids?
4.
1, 2, 3, 4. In plan, if you look, so this is 1, this is 2, this is 3, and this is 4. This point, and this point is along the over the height. Hello.
Okay.
Ashok sir. So go back to ETABS. Number of grid lines in X direction will be what? 4. And number of grid lines in Y direction, how many? It will be 1. Because if you are moving in this direction, okay, that we don't need to consider, but this line we are going to consider. If this is the first line, if I am taking another line, then I am taking another line. So this is the first, this is the second, this is the third. So along Y direction, how many grids will be? Hello.
1.
1. That's why we have to put it as 1. You are drawing it along the plane X and Y, X and Z. Okay. Spacing of the grids in X direction, tell me. What is the spacing?
4 meters.
Hello.
4 meters.
4. So just go back and put it as 4 meter. Go to ETABS. Put it as 4 meter along X direction. Along Y, nothing is there. So, but it is not accepting 0. We have to put it as 1. Anyhow, let it to be as it is. It is needed to go to custom grid option. Hello?
Yes.
Why?
Yes, sir.
Why it is needed to go to custom? Because whatever we need to do further, that is over the height. Along X it is done 1, 2, 3, and spacing is uniform. So why you are saying that we need to go to custom? Tell me fast.
Not needed.
It is not needed to go with the custom. Let it to be. Along the over the height, it is what? Over the height. How many levels we need to have?
3.
3 levels. Like, so ETABS software will by default give you one level as base. That is what? Foundation level. Hello. ETABS software will give you by default one level as the base level, which is considered as a foundation level. Hello.
Yes, sir.
Okay. That's why we don't need to count this. What extra levels are there? This is the first, and this is what?
Second.
Second. So only 2 extra levels we need to have. So number of levels, how many it will be?
2.
2. Just put 2 extra level. 2 number of stories will be there, and base will by default will be there. Typical story height. What is the height of the story? Tell me. Typical story. So first we need to have this level. Then we need to have this level. Can you guess how we can calculate these heights?
Trigonometry.
Sorry? Yes,
By trigonometry.
trigonometry. Like this is the 30-degree angle. This is what 30-degree, and this height we need to have. So 4 meter. See, height upon base is equal to what?
Angle equals to angle.
Tan.
Yes,
Height
tan.
upon is equal to
Tan
tan.
inverse equals to height.
Tan 30. So
Yes.
it will become what? Height we need to calculate. So height will be equal to base times your tan 30. Find out the value. Base is actually what? 2 meter. Half of this. Hello.
Yes,
2
yes,
meter.
sir.
So 2 times tan 30. Find out the answer.
1.154.
Anyone else fast? Cross check.
1.154.
154.
1.154. So this value we are getting 1.154 meter for this height. Now I need to have the total height. Actually I need to have this height, but I'm not able to calculate it directly. So first we need to calculate the total height. So find out the total height. Very simple. It is 4 meter, means it is going to become 2 meter, and I need to have the calculate height. So 2 times tan 60 at this time, right?
Yes,
Give me
sir.
answer. Hello.
3.464.
3.464
464. 4 meters.
meter. Now difference of these two level heights will be what? 3.462. Sorry, 3.464
Minus
minus 1.14. Tell me second height.
2.310.
2.310
310.
meter. So first height is at a height of 1.154, 2.310. So two heights are there. So it's very difficult. See, come back. Any typical story height is there? Any?
No.
Typical story means that the repetition. Only two levels are there, and both the levels heights are different. So there will be any typical height? No. So that's why I'm going to let it to be as it is. Bottom story height, let it to be as it is. So we know we need to go to custom or not?
Yes, sir.
Yes. Go to
Custom story
custom.
data.
Go to edit grid data story. So base will be 0. First level will be at a height of what?
1.154.
1.154. Second level is at a height of what?
2.310.
310. Say enter. So total height is going to become 3.464. It is right or wrong? So this is what the elevation which is showing the cumulative height. It
Okay.
is showing what? Cumulative total height. So first 1.4, it is same height. At this level 2.331. So this height plus this height will give you total elevation of the level, total height of the structure. Hello.
Yes, sir.
Okay. Now simply say okay. After that we need to have the grids. So check these grids. Let's say simply okay. Once you click over the okay, this kind of window will be there. One is plan view and second one is the 3D view. But we don't need to practice over the 3D view. Close this. Now it is showing the plan view. Another thing, it is the plan view or elevation view? Tell me fast.
Elevation view.
It is the elevation view. So what I need to do, I need to look at the elevation along the grid first. I need to look at it is the plan view. Line, only the line is visible. So I need to have the elevation along the grid first. Hello. Along the grid first. So go to elevation along the grid first. Say apply. So see, this kind of presentation will be there. In elevation, you can also see the labels of the story. Hello. Okay. Now, just go to this frame element we have to model the frame. So just take this option frame, and whatever is there, let it to be as it is. Actually we have to discuss lot of things for modeling, and what does mean by this option, everything that we will cover later. Okay, right now our objective is only the validation. So let it to be as if whatever is there, close this. Hello.
Yes, sir.
Okay, now I have to prepare the model for this. Okay, so from this point, go back from this point. See, I am going to click here as I am taking my cursor here, so it is intimating that what a particular point. So unless and until you are not getting the sign like this, don't click over that, because it will create the it will create the modeling error. Okay, so you have to take your cursor here and then click over that. Once you click over that, that start point will be done, and you have to take your cursor to this side and over this line. I have to find out the midpoint. Is it possible for me to get the center point?
Yes, sir.
How?
In draw option, we can go to snap option, draw a snap. There
That
we
is
have
only the option to access the snap option, or is there any other one?
I only knew about that, sir.
Okay. Yes. Good. See. Okay. So my intention is what? I want to see the center point, because I just want to move from this point to this point. So how I can access that center point? How I can access? Okay. There are so many assumptions that we have discussed, like loads will be only at the joints, all the sections of uniform cross section, all the elements having the uniform cross sections, all the members are connected their ends only. So it will not be right if you are taking the element from this point to this point directly. If you think that it is along the one lines, so why we are going to break it at this point? Why we are not taking this continuous up to this end? So it is the assumption. It is a real practice where we are considering the element from end to end and point to point. Getting? And all
Yes,
this
sir.
connection or these joints are the pinned connection or hinged connection. Means what? This joint will not carry any movement. This joint will not carry any movement. It will transfer only the axial forces. Right? Hello.
Okay.
Clear?
Okay, sir.
Okay. Now, so here I need to have the center point. So very simple is what I need to have the center. So right click on your mouse, and here once you right click, a new pop-up will open, and it will ask show you different option. One option will be there, snap option. Hello. Just right click over that. So many things are there that we will cover in the command section, but some important things, if suppose you want to have the center points, so line ends and midpoint, this option is not checked, so you have to check this option and say simply apply. So this is done. Now you will be able to see the center point. Hello.
Yes, sir.
Okay, so take another again this frame element, close this from this point. Unless and until it is not showing you red sign, don't click over that. If you are not getting that red sign, zoom it, then click over that. Okay, so after clicking over this, just take your cursor to this side and then click here. Hello, midpoints. Now coming back to this. Hello, is that all okay?
Yes, sir.
But see, why it is automatically has assigned by default, it has assigned the support to this point. I have assigned this support. No, so why the software is doing this thing and
By default, it is
unintentionally?
showing hinge support.
No. Why it is assigned? That is the question.
Because it is truss, Anna, so
Sorry.
because it is a truss.
No. Why it is not assigned at this level?
Okay, that's the final question.
Shubham. Ritesh, Sanskriti, do you have any idea? Sanskriti,
No, sir.
no idea. Ritesh, why it has assigned the support to this point? So yeah, actually what it is the base
Base
level, as I
level पे
told
है.
you. Yeah, it is the base level. The software is considering this base level as the foundation level. So it automatically, whatever you are going to do at this level, software will just instantly will assign the support as a hinge support every time. Okay? Because in the
Okay.
base level, software it is considered as a foundation level, and by considering the foundation level, it will assign the support. Getting or not?
Got it, sir.
Okay. Now again, so remember, close this. Now frame element, how to model the frame element? You have to click the first point, and you start point, you have to click over the end point where you want to end your element, and you have to start from your where you want to start your element. That is the way of modeling the frame element. Frame element like beams and column. Okay, so this is the point I want to start. This is the first point. So beam is okay. Now it is the command is active. Command is active, and the command is continue also. Command is active plus the command is continue also. Not getting. Wait. Undo. I want to draw the frame or model the frame. Close this window. This is the first. Now the command is active. Previously, if I am clicking here, the command is now inactive. I want to active the modeling command for the frame. Click over this. So your command for the modeling of the beam is now active. Click on this first point. Move to this point and click over this. Now the beam is modeled, but the command should be inactive mode, but it is still inactive. Plus the continuity is there. So if I am taking this at this point and clicking here by taking the help of continuity, I will means I am going to model the next beam. Now come to this level, I will model the next beam. So this is done. But see, automatically it has assigned the support. Getting?
Yes. Yes, sir.
Now second, again the command is active, and I need to have the command to be active, but the continuity is there. Tell me, can I go anywhere with this continuity right now? No.
No, sir.
No. So what? I will right click on my screen or right click on your mouse. So the continuity will be off, but the command is
Active.
active. Getting or not?
Got it, sir.
Okay. Now again from this point, I have to take this line. Click here. Now I can take the benefit of this continuity. Move here, then click here. It will assign the support once, okay? Not again and again. It will assign once, okay? Now click here. Second, now come back to this point and then click here. Now of this command, continuity, command is active. Click here and come back to this point and then click here. And then right click on your mouse. Now this is all done. Now is there any use of this command to be active? See, is there any element is remaining to model?
No.
No, all the frame elements has been modeled. So just click here. So the command will be inactive and everything is now finished. Understood or not?
Understood.
Is that all clear?
Yes, sir.
Okay. Now let's talk about like first we have to complete the modeling. So what I told you, see, okay, first understand. Okay, first understand the break command. Actually, see, it is what completely I have modeled from this point to this point. It is right. At every intersection point, your model will be your element is going to be break divided. It will not like that. In case of truss, the element is like this, and another element is going to rest, and another element another element end is going to be land over the mid portion of any element. It will not happen. Always two elements will be joined at their ends only. Hello. So here it is what happening. It is going to be this element is going to land over this at the mid of span of this beam. So it is right or wrong?
Yes,
It is
sir.
not
That
correct.
means
It is wrong.
a
It
truss
is
is made up of number of sections. Uh, consist of joints means
yes. So it is what we have to break at this joint. What we
yes,
have to do? We have to break this
line
complete line in two
and
parts
made it.
at this
Yes,
joint. So what?
yes,
How
sir.
to do that? Select the frame. Select the frame and select the joint about which you want to break it. Hello.
Mm-hmm. Yes,
Select the
sir.
frame and the joint about which you want to break it, then go to editor and then go to edit frame, because it is what editing work. It is not assigning work, it is not modeling work, it is not design work, it is not schedule means analysis work, detailing
Okay.
work. It is what edit. We have to
Editing
do
work.
the modification in existing thing, editing work. So select the
Okay.
frame, select the joint about which you want to break, go to editor, go to edit frame, and in
Yes.
edit what we have to edit, either frame or shell.
Frame, sir.
Frame. So go to edit frame. Here the option is there, either of joining the frame or either of dividing the frame. So go to divide option. In the divide into number of elements, like 2 3 elements. Or second option is break at intersection with the selected frame and join. For the particular
Okay.
frame, for the particular selected joint, I want to break it, just say simply apply, so it is going to be breaked. Hello,
Yes, sir.
understood or not?
Understood.
Undo this step. See, while practicing this, I have clicked on apply, not OK. There is another logic. Hello,
Mm-hmm.
select this frame and select this joint, then I'm going to apply OK. So it is going to be breaked. Our intention is now executed. It's okay.
Yes, sir.
But what? See, if I'm clicking on OK, undo this, select the frame, select the joint, and keep this option and say simply OK. So say simply OK. What is happening? It is again going to be breaked. No, it's the same thing as then what is the difference of clicking on apply and clicking on OK?
After applying, we have two options to close the window. That is either we can close or we can press OK. So then that window will be closed.
Yes, exactly. The thing is what? Once you click over the OK, the means your action will be done, but the window will be closed. If you have to repeat the
Yes.
same thing, then you have to access that option. That is what repetitive work will be there. Time consumption will be there.
Yes.
Getting? So
Okay.
what? That's why uh,
If
select the
number
frame,
of
select the joint, go to edit, go to edit frame, go to divide frame, and check this option and simply say apply, so that this window will be in this window will be there, so that you can use this window multiple times. Say
yes.
apply. So this is done. This is the frame, this is the joint. Okay, select this frame, this joint, then say simply apply. This is going to be breaked. Okay, so this is done. Hello.
Yes, sir.
So all the elements are separate elements. All the individual elements are separate elements. Okay, this is the first thing. Second, about of assigning the support. So there are three types of the support. One is your roller support, one is your hinge support, one is your fixed support. Hello.
Yes, sir.
One is your hinge support, one is your roller support, one is your fixed support. So there are three types of the support. Am I right or wrong?
Yes, sir. You are right.
Okay, very simple. You all know. I can understand. Okay, so for the roller support, how many reaction will be there? One reaction. For the hinge support, how many reaction will be? Two reaction. For the fixed support, how many reaction will be? Three reaction.
One will be moment.
Movement. So three
Yes.
reactions will be there. So let me know for this truss on left hand side, it is what? Hinge support or roller support? Tell me.
Hinged.
Inch.
So go back to your ETABS. So I need to first let me know, is there any support at this point, B and C?
No.
For B and C, is there any support?
No.
So select this joint, select this joint, I will let you know by tomorrow how to make the selection. There is a brief discussion about the selection. Okay, so that we will cover by tomorrow. But see here, select this joint. The joint is selected. How many selection of joints are there? Look at this. While working with the ETABS software, always your concentration will be on the bottom left side. Always your concentration will be on bottom right side. Hello.
Okay.
What is the importance? I will let you know in detail later. Okay. But right now, just remember your concentration should be on this side, left bottom, right
Okay.
bottom. Okay. I will let you know in detail. So here the joint, how many selections are there? Hello. Left bottom will show you the selection. Okay. How many selections are there? One joints selected. Either drag from left to right, and this joint, how many joints are selected?
2, sir.
2. Okay. So I just go to assign. Now it is the assign work. I want to assign something to joint. This joint. Assign means what? Go to assign and go to joint option. Go to restrain. Restrain means what? Assigning the supports. Go to restrain. So all the options are available. See, restraints. So here it is the fixed. Here it is the what? Hinge. It is what? Roller. It is was none. So we need to go to none. Say simply apply. So nothing will be there. Getting or not?
Okay, sir. Got it.
Got it. So it will be none. So no any kind of restraint is there. Actually there is a discussion for the support. I will cover that also. Okay. So it is what? None. Now on left hand side, see I am going to click on apply, not OK. If I am clicking on OK, so this window will not be will be present. Okay. So you will be in trouble to go to again assign and finding the joint and then restrain. Aklesh, getting?
Yes, sir.
Okay.
Got
Now
it.
drag from left to right and this joint is selected. But see, hello.
Yes, sir.
See, joint is selected. One joint is selected. Drag it. One joint is selected. And for this joint, what is the support?
Hinged.
What kind of support is there on left side?
Hinged.
Hinge support. So second option, check this hinged support. Say apply. So it is actually by default hinge. So no change will be there. On right side, what is?
Roller.
It is roller. So take this roller one. Say apply. So it will be roller. Understood or not?
Yes, sir.
Okay. So this is the thing that we have covered by today. Okay. So many things I have to discuss for this. It is not the end. It is only the 50 or 30% of this trust we have covered. Okay. So many things we have to cover that we will see by tomorrow. Is that all okay? Hello.
Okay, sir.
Yes, sir.
Ashok sir, Sanskruti, Bhushan, Akshay,
Right, sir.
Akhilesh,
Correct.
Yes, sir.
Akila.
Yeah.
Okay. So shall we conclude the session?
Yes, sir.
Okay, so we will meet back tomorrow at 7:30. You will get the link. Okay, and extremely sorry for today. We missed to send the link on Telegram. So most of you are confused whether the session is there or not. Okay.
Yes, sir.
Yes, sir.